let's get started. Anna Abramova from SqlDBM, and we have two guests that neither of them needs an introduction, but I'll still do the, do the pleasure of it. We got Kent Graziano, also known as the Data Warrior, recognized industry thought leader, award-winning speaker, author, and as we all know, semi-retired Snowflake Data Cloud and Data Vault evangelist. And as of recent, Kent, you joined us, meaning SqlDBM, as a strategic advisor. So welcome, Kent.
Thank you.
And we have Serge Gershkovich. And Serge, I believe you have kind of two main things as your titles. One is a Snowflake Data Superhero, and the other one is here at SqlDBM, you are a developer advocate.
Yes, and I wear them both equally proudly.
Those are really good titles to have, so we're glad to have you. Glad to have you both. I'm actually here just for the introductions because I know, Kent, you have a lot to share in terms of data modeling. And then, Serge, you prepared some live demonstrations for us.
Yes, I did. They're ready to go.
Perfect. Good. Kent, maybe to get us started on the right foot, I know you and SqlDBM go way back. And kind of you've known of SqlDBM data modeling before we were mainstream. So maybe tell us a little bit of backstory and then go into your vision of kind of where is data modeling now in terms of the Snowflake Data Cloud? Kind of where do we stand and what are your thoughts around it?
Sure. So yeah, going through my notes here, as SqlDBM actually reached out to me back in 2018 to get my thoughts about the product and about data modeling and how it might fit into the Snowflake world. Because in my life prior to Snowflake, I was very heavily into data modeling in the Oracle world and helping people with design and development and architecture back then. So that's kind of where my introduction came from, was Ed reaching out to me directly, and then me helping get him connected with all the right partner people at Snowflake. And then SqlDBM was able to support Snowflake as early as 2019. I encouraged them to work on a direct connection rather than just using a generic ODBC connection or JDBC.
Yep.
And so you went to town and got that direct connection into Snowflake, which made things work so much better. And as a result of that, and growing over time, you guys now are premier technology partners, recognized as a premier technology partner with Snowflake, which is a massive achievement. And it's been a lot of work for a lot of people over the last couple of years to get to that point. But it's SqlDBM is probably the most highly adopted data modeling tool for Snowflake because of the fact that it supports the native features of Snowflake so well. I was intrigued initially, certainly because of the fact that it's a SaaS, right? It's cloud-based.
Right.
It's all hosted in the cloud. No installation to do, and just like with Snowflake, it's like we're moving into a new world, and all of the other data modeling tools that are out there were all on-prem. And just like we said with Snowflake, it's like, why would you want to stick with a on-prem database that's been ported to the cloud? You want to use something that's been built for the cloud like Snowflake. And SqlDBM followed that model as well, and it doesn't have an on-prem version. It was built for the cloud, and it's just like the perfect pairing there, the right kind of data modeling tool for people to start working with their data in the Snowflake Data Cloud. So I was very pleased to see that evolve over time, and one of the reasons I agreed to be an advisor for you guys is of all the modeling tools that I've worked with over the years, and I've managed to make multiple modeling tools work with Snowflake. SqlDBM, there was no work to it. There was no work involved. It as they say, like we say with Snowflake, it just works, right? And so connecting it to Snowflake was quite easy. Now, as for the world of data modeling, this comes up constantly on LinkedIn. It's kind of a shame we don't have LinkedIn Live, but oh well. I
Yeah,
guess
next time.
we'll post it out there for people to listen to this afterwards. These discussions come up weekly. It's really hard to stay retired with these conversations constantly coming up about the value or not of data modeling, because they're never short discussions. There's a lot of us in the industry, like myself, who have been doing it for 30 or 40 years, that it's hard to understand why people don't think data modeling is important. The whole data lake, data swamp thing, I think, man, if that didn't convince people that not modeling your data is a bad idea, I don't really know what would, because we went through 10 years of quote unquote no SQL and just-in-time modeling and schema on read, and people going, well, yeah, schema on read's great, but we don't understand what we're reading, right? Because there's no model, there's no metadata, there's no nothing. And it's like, okay, you're looking at a whole bunch of raw data, and the poor data scientists of the world are out there having to spend 80% of their time figuring out what's actually in the data. And if there had been a model of the data, well, that would have been their guidebook. Every data scientist that I have talked to, they don't necessarily know what a data model is. They know what an ML model is, right? And they think of the model of the data in a very different way. But if you show them a diagram or give them a data dictionary and say, hey, wouldn't it be great if you could look at this data and say, okay, here's all the tables in the schema. Here's a definition of the data in each of those tables. Here's a definition of the meaning of each of these columns. Would that help you? And of course, all of them say yes. Of course it would help me, right? If I had that information, I don't have to go figure it out myself, and I can get to the work of being a data scientist faster.
But Kent, data modeling is hard. I don't have the time. In fact, no one has the time on my team. We're so busy delivering that. How can I get these diagrams? Where do they come from? In fact, let me take off this ridiculous hat, because LinkedIn Live isn't happening, and we had a whole thing of we're in the jungle. So let me put on something a little bit more appropriate. Here we go.
There we go. Yeah. Okay. Yeah. I mean, this is the fallacy of the whole thing, because this started back in the day of Agile. When people started Agile software development, back then they stopped modeling data. They were still doing development against databases, but then they didn't model the data because, it takes too long. Well, yes, the way it was traditionally done in large organizations that were doing top-down enterprise modeling with a team of thousands, trying to get the perfect logical or conceptual model of the data in the enterprise, and they would never let anybody build anything until that model was signed off on. And I saw multi-million-dollar projects like that fail, 20 and 30 years ago, because it just, by the time they finished the model, the business had changed. And they hadn't delivered anything. And then it went to the DBAs, and the DBAs said, well, this database we're using, that won't work for 15,000 different reasons. And so then they rearrange it. And that takes a whole bunch of time. And then when people try to use it, once they load data, it's like, well, okay, the queries are too slow. Okay, well, so now we got to get to indexes and all these other things. And it just took way, way too long. And so that certainly gave the impression, not unjustified, that data modeling was hard and it was going to take too long. And I'll say, yes, the way it was traditionally done, in many cases, that was true. But, we've got a couple of things going for us now. In the cloud, we're fighting this battle too of, well, it's in the cloud, we don't need to do data modeling, just like we said with Hadoop. And it's like, okay, that's just wrong. You still need to have a model. You still need to understand, even if you don't develop an enterprise model, you still need to have a way to communicate to people the content of the data. I mean, we used to call that metadata. Some people called it a data dictionary. So at a minimum, you want to be able to look at the structures you have coming from your source system. Do you need to go through and design a star schema before you do anything? Well, probably not. but you still need to know what's in the data. You know,
Exactly.
there are cases for doing that. There's definitely great use cases for building dimensional models and building data vault models and building third normal form models. But at a minimum, you want to at least see what's there in the data today. And your definition of data models changes, right? Are we talking about logical and conceptual models? Or are we just talking about physical models and understanding the data we have at hand? And we have to start somewhere. In the data warehousing world, I always had to understand the source system. So I needed to see what was in the source system that I'm going to try to do analytics on. And that's something, again, where SqlDBM comes in and be able to reverse engineer those tables. If you use something, say, like Fivetran, to load a bunch of data into Snowflake from the source system. All right, well, what's in those tables? What are the column names? What are the table names? You can reverse engineer that into SqlDBM and have a diagram, and then start looking at those definitions and have a place to catalog it and to create that data dictionary. Now, as you move forward and you're trying to integrate multiple source systems, yeah, you do need to come up with some kind of a common model that's more semantic based. And that's when we start talking about things like data vault and being able to articulate the meaning of the data in business terms that is, I'll say, I was going to say divorced from your source systems, but really it's source system agnostic. It's, from a business perspective, what's the meaning of this data? It doesn't matter what the column is in 5 different sources of what the column name is. What are we going to call it? So that the business people doing the analytics and the data scientists doing the analytics and building machine learning models, that they know what that data is. And that calls for a common model. And so that's another piece of it. But you don't have to do it all to start. And again, that's the fallacy that people didn't understand in the Agile world, is if you take an incremental approach to it and you have a tool where things are being documented, where you've got some change management in place, then you can build this a little at a time. You don't need to have the whole thing done. Is there skill to it? Is there a learning curve? Absolutely. If you take somebody who's never done data modeling, it's going to take a little while. You don't throw them off the deep end into dimensional modeling or data vault modeling. Okay, teach them, reverse engineer a source system and start understanding that model and understanding the content and the context of the data through data models and data model diagrams.
I think you just hit on a very important point there, Kent, in the sense that there's really 2 use cases for databases. One is on the application side and one is on the data warehouse side. And I think that most of the attention of the data world is in the data warehouse because nobody's running reports, nobody's building dashboards, hopefully, on the application side. And on the warehouse side, the advantage you have is just the fact that everything's already been modeled for the most part, at least in the source, in the raw schema. All of these tables already have structure. So sometimes it's easy to forget that somebody had to go in and agree with the business what these tables, what the data in these tables should look like, what it should relate to, what it should connect to. And the debate, as you said, of is data modeling important? I doubt very many people are so far removed that they've lost sight of the fact that somewhere, somehow, someone is modeling the data for them. It's all about understanding where can you get the tools. And everyone, like you said, every data engineer, every ML analyst knows the pain of saying, I've been asked to do a job. I have no idea where to find these artifacts. I have no idea where to find this data. A dictionary, a diagram would be immensely helpful. And the old world thinking of, yeah, we had to draw all this out on a static diagram and nobody maintains it. A lot of this is being driven by that false assumption of it's hard to maintain, it's hard to keep up to date. So we're gonna look at that in just a minute, at least our approach to doing it. But
yeah, I mean, the reason it's hard is because of the processes. It's always people and process, right? Technology just enables us, but you've got to have that process. And there is a discipline to data modeling. Just like there is in software development, right? We've got to follow somewhat of a standardized procedure. We have to have rules of engagement. Where it was challenging is where you have multiple data engineers and DBAs accessing the schemas and changing things on the fly and not communicating it to anybody. Well, yes, then the diagram you might have built now it gets out of sync. And like I said, I think you're going to show us how you can fix that. But the solution to that problem is putting a process in place. Is if you think you need to make a change, we use the data modeling tool to make a change. And we keep the data modeling tool up to date. But that is a discipline, right? That is a discipline that has to be an agreed upon process. In all the Agile and Scrum teams that I ran in data warehousing, we lived by that. Nothing went into the database if it wasn't in the data modeling tool first. And all the code we used was generated code. We never hand wrote any code for building tables and loading tables. We generated the models from a modeling tool. We generated the ETL and the ELT from one of those type of tools. The only thing we ever might have written manually is sometimes we wrote views to test out things, to see, to show the end user how the data might look. Because at the time, the data modeling tools we had didn't do views very well. So we ended up having to do a little bit of hand coding that way. Then we would eventually reverse engineer that into the tools. So, it's about a discipline. And it's about an approach. It's also about having understanding the value of having that model, and it's a long-term value. Does it take time to build a model? Yes. If you've got a 10,000 table schema that nobody's ever documented, okay, that's going to take a little time, but you can hone in and focus on, well, let's just do this piece of the model that we currently have questions over and build it incrementally. And that's the dynamic nature of a tool like SqlDBM allows you to do that. And it's not an all or nothing. And I think that's where a lot of people get lost, is they think it's kind of an all or nothing thing, and they don't see the value of doing things incrementally. So one step at a time, right? Every journey of 1,000 steps starts with the first step.
And I really like the point you made about it being a discipline, because as a discipline, that doesn't change. That's been there since database systems came onto the scene. But what is changing are the tools. The tools are getting better. So the amount of time it takes to keep this current, the amount of time it takes to share with the team, that gets easier and more agile. Whereas the discipline, it needs to be there. It needs to exist within the team. So I wanted to ask you one of the key questions, since, as you've said, you've seen multi-million-dollar projects go down the drain because a lack of coordination, a lack of just a common understanding of what is being built. So how do you articulate to even a modern warehouse, modern architect, or modern data team that, yes, this still takes a little bit of time, but actually you're just thinking about it wrong. You're trying to gauge too tightly the amount of time you spend in a modeling tool, and you're ignoring all this time you spend running around asking people, where is this data? How do I link it? How do I get it into my report? What do you say to people like that?
I mean, basically, you just articulated it yourself, and it's about the the total cost of ownership and the time to value, right? You have to look at, okay, what are people doing today, and how much time is it taking? All right, well, how long did you think it was going to take to do the model, right? And if they have no experience, then the only option you have is to show them, right? You have to demonstrate it to them and demonstrate the value. Over half of the consulting engagements I had, I guess really over the last couple of decades, started with me reverse engineering an existing schema, because there's a problem. They don't know what the problem is. They swear that they've got X, Y, and Z in their database. You pull it into a data modeling tool, show them the diagram, and the shock on their face is obvious, right? It's like, wow, we didn't realize that's what we had in the database. They just been writing SQL statements against a couple of the tables, and they didn't know this other stuff was there. They didn't know the column names were wrong. They didn't know that they had the data types wrong. They had things that should have been numeric that were in there as character. All sorts of things that they just didn't know because they never looked at it that way. And sometimes, again, it's seeing is believing. So you kind of have to show it to them. The other option, and this came up a lot in the last couple of years when I was talking to people in particular, were asking about Data Vault, is I'd ask them, why are you wanting to look at Data Vault? And it was the answer was almost always, what we're doing isn't working. We look at what we've done for the last couple of decades, and we're not getting the value we expect. It's too hard to change what we have. It's too hard to integrate a new source system. And so there's all these things that if you start digging in a little bit, you have to sort of challenge their concept of the success that they've pretended they've had for the last couple of decades. And say, what are you doing today? And then the honest question is, how's that working out for you? Are you achieving the goals you want to achieve? And, you know, is it worth maybe taking a little time and investing in a data model to see if that helps? Now, don't spend 6 months or a year trying to model the entire universe. Just take one problem area. Let's pick a problem area that you have in your data warehouse today, and let's see what we can do. Let's go look at what you've got and see how we might be able to make that better. Exactly. You know, try to get the quick win. Again, it's you know, the agile mantra of fail fast, right? Is, you know, say, well, just do this quick. So if it doesn't work, you know, we're done. But you know, in the back of your mind that, well, we know it's going to be successful if we do it right, and that has an equal value to them. That it's
a great advice, because a lot of people, they come to us and they're just overwhelmed. But I love how you said it, Kent. Don't try to model out the entire universe. Start small. And I think we can really help with that. Speaking of starting small, we're at the half-an-hour mark. I do know that Serge also wanted to show us some things.
Yeah.
I don't know, Serge, is this, and I also have, thank you, everyone. There's a lot of questions. I'm looking through them, and I'm going to pick. We're probably not going to go through all of them, but at the end, let's save some time so I can handpick a couple of questions, Kent, for you, and Serge for you as well. And we are, by the way, live on LinkedIn as well right now. So
nice. Okay, awesome. So let's enough pontificating about the importance of data modeling. Why don't you we'll allay some fears here, and you know, you can go ahead and show them how easy it can be with SqlDBM to get started.
Exactly. So we want to dispel these myths right on the spot, right in front of you, just so you see how much time modeling actually takes versus how much you think it takes, how hard it is to share and involve everybody from your team versus how much you think you're going to spend running around getting people to buy into maintaining, participating. It's added value. So it's not extra work, it's added value for everyone. So let's see how that looks like. So SqlDBM, as those of you who are familiar with the tool are aware, it's a cloud-based tool. So it lives and breathes the ethos of cloud, just like Snowflake. Nothing to maintain, everything handled for you. All the updates happen natively behind the scenes. And because it's in the cloud, it's also easy to access. So you can access it from a browser, from any platform. Any user, any PC, Mac can get to a data model, and it also makes it easy to share with the rest of your team. So include a link, include an email address, and your colleagues are participating and seeing the same thing that you're seeing. So I'm told data modeling takes a lot of time. So let's see if that's accurate. Let's go from zero, from no project. I have some projects here that we're going to look at shortly with some neat features pre-configured, but let's go start from scratch, and feel free to time me, Anna, Kent.
Okay.
And I'm going to spend most of this time talking, but it doesn't matter. It's still going to be a good result, I think. Zero to Snowflake. We do support other database flavors, but we're going to focus this demo on Snowflake specifically. So let's go bring an existing database.
Yeah, speaking of direct connection, speaking of directly connecting to your Snowflake data warehouse.
Exactly. Speaking of it, let's see what else being in the cloud allows us to do. So obviously connecting natively, all we need is a URL user, and we can connect and get that DDL. So we don't even have to go to the database separately to pull that out. We connect. This allows us to look at all of the databases we have. So as Kent said, we can start small. Let's start with a single database. We can do one schema or multiple schemas, and let's bring in that DDL. So right now we're just running the get DDL statement. We don't even need a warehouse. We're not reading data. We're not changing anything. And we could have done this manually via file, but that's the power of cloud. Being connected to another cloud-based platform allows us to quickly get this, hit upload, in which we'll parse all of that into the individual objects that will now form a part of our object catalog for the project. And we're just going to generate a couple of diagrams to get started. So then we can slice and dice these. We can organize these any way we like, but hitting import will get our project instantiated. And let's just arrange these. And there we go.
Yeah.
We're up and running. So we have two schemas in this case on a single diagram. We've also done separate diagrams per schema, but the important thing is we have something to look at. We have a starting point for talking about our landscape, communicating the data inside these tables. And as I like to tell people, it's not just that it's a modern looking tool. It has the neat dark themes and dark screens that everyone likes. It really is the power of cloud. It's the fact that via this browser, we'll take a look in just a second, I can invite people and have them start participating as quickly as it took me to get this diagram up and running. So I can look at it at different levels of detail. So this is obviously the physical layout. We can, for example, as a developer, maybe this is too much detail. I just want to see relationships. So I can, in the keys view, take a look at just primary and foreign keys, ignore the attributes for the time being. I can also start maybe grouping these by visually to make them easier to find. Let's say there's no constraints linking them, but they do belong to the same team or department. So we can start giving this some color. But what we can also do is we can go even more abstract and show these to a non-technical, a business user, a project manager, to start that conversation of don't worry about data types, don't worry about indexes. Is organization related to account, and how are they related? What are they linking on? So even though I'm switching the level of detail, what I'm really pointing at is still the same single source of truth. I still have all the physical objects right here. I haven't converted anything. If I click on this table, I still see Snowflake-specific properties like transient and data retention. I can still click in even if I need to take the discussion a little deeper and see the underlying columns, get at those properties as well, which, as Kent was suggesting, works in two directions, because right now we're going backwards. We're taking an existing architecture and we're modeling it. So it's technically already been modeled. We're just putting it on a diagram that we can now share with the rest of our team members.
Right, and I think that's a good distinction to make. This is not data modeling. This is exposing the existing model that you already had. So which is where the value is in many cases. If people didn't know how this data was related, now you can see that. And I think it's also worth pointing out, in this case, you've reverse engineered I'll say, well-modeled schema. It's got foreign key constraints, it's got primary key constraints, they put table comments in there. Otherwise, you wouldn't have this metadata saying, the fact table to hold currency data, that fact internet sales is a fact table to hold currency data. That was all stuff that was already in the Snowflake database. If that stuff's not there, and you just get a whole bunch of tables that don't have any relationships, then we can then use SqlDBM to refine that model, right?
Right. So Kent is just laying them up for me, and let me take that to its logical conclusion, no pun intended. This model is properly modeled. There are physical keys. It makes it very easy for me to draw these relationships. It also makes it very easy for third-party tools who are pointing to Snowflake, let's say your reporting tools, your Tableau, your Power BI, they know to look for these physical constraints and indexes and, sorry, not indexes, foreign keys. And they will also see this. They will propose joins when you're doing your reporting, when you're looking at this in a cataloging tool. But traditionally, a lot of people have just neglected to assign these, neglected to do the due diligence of declaring them when the time was right, when they were building them to begin with, when the knowledge was still fresh in their minds. So in order to bring these people into the fold and say, you are not, it's not too late, you can come and you can do data modeling. What we've just released is a feature called suggested relationships. So suggested relationships, what it'll do is, if you've got no primary keys whatsoever, no foreign keys, obviously, you can set up a couple of keywords to guide this process to say, what do your keys look like? Because whether you like it or not, all these tables, all this data will naturally have things that will hint at being primary keys, things like ID or code or PK or B key or anything like that. More than likely they're in there. So you just have to tease them out. So if you give us a couple of these keywords and you also tell us to exclude others, for example, nothing with date, nothing with amount, those are obviously not primary key candidates, then we can go ahead and suggest them for you. In fact, let's take a look, because this is already a large enough schema where it's easy to get confused. Let's take a look at a very simple example where, just like Kent said, what if this hasn't been done? So let's look at suggested relationships, where I just have 4 tables where it's very easy to see what links to what and what's missing. So we have bookings, clients, destinations, and hotels. No primary keys to speak of, no foreign keys. How do we get these? How do we get these related? So with suggested relationships, again, we have these patterns. We're already suggesting a couple. You can add your own. And the first thing we need, obviously, are primary keys. So if we look based on those naming patterns, we can see, for example, we can propose them for you. We can allow you to refine and edit of, okay, so actually client ID is not part of the booking primary key. I want to ignore clients completely or not. Let's say hotel or destination also is just destination ID, and likewise hotel. If I create these, for now they're virtual. So if you've already not declared them physically, we're not going to force you to change your whole structure of your database. So they're virtual, they're metadata so far within the tool. You can make them primary physical if you wanted to. But the important thing is now linking the tables. So now that we have some kind, whether it's metadata or physical primary keys, it's very easy to link these things together, because anywhere that destination ID appears outside of destination, we know that there's a foreign relationship there. So doing this, again, these are virtual. You can make them physical if you wanted to, but again, we've just taken a completely disconnected schema and linked it together, where just like as if it were modeled properly, what did that take us? A minute, less? Again, I've been talking the whole time, so it could have been less than that, but it's a really good way to clear that technical debt and get to the important stuff of sharing, communicating, collaborating. And what does that look like, you ask? Let me go back to the big project that we had before. So this is still the same schema. It's the AdventureWorks. Some of you might recognize it. Now, this is what a working project, working model might look like. So we're going to look at this in pieces. So one of the things you'll notice here is it's not just me who's participating in this project. So I have a project team that I've added. So just typing in an email, I can say, for example, Anna, I want you to participate with me in this, whether as an editor, a modeler, or just a viewer. There's still a lot of value that you can get out of using this tool. So we've been focused on the diagrams themselves, but it's more than diagramming. Once we make it easy to involve people, there's a lot of other features that you can leverage, a lot of knowledge that you can get out of people's heads, out of the team silos, and into a central repository. So these little, for example, speech bubbles that you're seeing here, that is collaboration communication. So now that you've got multiple users, you can, for example, you have a question or you're validating a new design. So you just type the @ symbol and you pick someone from your team and you say, you know, can you confirm? This person would get an email, they would come in here, they can go to the comment screen to search for either their name or your comment and jump right to the actual object and have that conversation in the context of where it was built and involve other people from the team if need be. And one of the other important things is going beyond, as Kent noticed, proper data modeling includes not just relationships, but also comments. So in the one I brought in, we already had some table descriptions, but wouldn't it be great if we had that for the whole project? And in this case, because again, some of these, you know, with bookings and hotels and clients and destinations, it's kind of simple, kind of intuitive to see how they relate to one another. But if we're talking about modeling in the Snowflake sense, Snowflake gives you a lot of potential options of how to work with data. So these are structured tables. You could, in theory, also be working with semi-structured data, and there's full support for that as well. So for example, if you've got arrays or objects or variants, the great thing about a modeling tool, especially if it's already been designed to work with not just a generic logical model, but an actual physical database, in this case, Snowflake-specific. If I type, for example, variant or any var, for example, it will suggest just the Snowflake-specific data types. So we have variant, we have array, anything you can expect. So a lot of times, especially if you're starting out, if you're adopting a new platform, this isn't just a gimmick. This is something that saves you a lot of time of not having to check the syntax, check the API. All of the options are at your fingertips, even on the columns as well as the object itself. If you know what properties apply to an integer column versus which properties apply to a character, etc., it saves you a lot of time of not having to go back and forth or even discover properties and options that if you have no idea what data retention is, you see it here and you go and investigate and you say, how can that help me?
Yeah, I want to jump in there for just a second, Serge. This is one of the things that with other data modeling tools, getting into Snowflake, in particular, the variant data types, I'm glad you showed that, is that doesn't exist in other databases. This is something that Snowflake invented to hold semi-structured data. And I had to go to basically figuring out how to create a custom data type in some of these other tools so that I could build models that generated DDL for Snowflake that had a variant data type. But that didn't solve the problem of existing models, because anytime I tried to reverse engineer anything from Snowflake with some of the other tools, it just came in as like a varchar 5000. It didn't know what a variant was, and it didn't recognize the geospatial data types or any of the other specific data types in Snowflake. And that's, again, one of the values, I think, from SqlDBM is that it is tightly coupled with that direct connection to Snowflake and recognizing those specific Snowflake data types, whether it's reverse engineering or forward engineering. And that is, as Serge was saying, that's a huge time saver, right? To be able to do that, not have to do it manually and you generate some code and then have to manually tweak it because it's not quite right. It comes out of SqlDBM exactly what Snowflake needs.
Yeah. So another question I might ask of my data model is, here's my customer table. Where is this coming from? Is this, does this come from CRM? Does it come from the source system? And a lot of times this is the stuff that you are going to want to maintain in the data catalog. So what's the difference between documentation and cataloging? The difference is you're not just documenting your development artifacts. What you should be doing, especially in a collaborative tool, is leaving these crumb trails for anyone that'll come along and want to understand more, since with a simple interface, the barrier to entry, that technical limitation, isn't there anymore. Anyone can come in here and, for example, fill out the descriptions, the business logic, the formulas behind these things, some of which a developer might not even be aware of. It's only someone on the product side or on the application side that might be able to provide that kind of context. So to my earlier question, if I ask, do we have anything from Salesforce? Now I can go and search through my entire catalog and see, are there any tables? Are there any columns? And if there isn't, it'll even look down to the description level to find that keyword and say, oh yes, someone has come in here and left me a comment. So one of the things that we recommend that people do is obviously make use of this, obviously include more than just the developer team in a tool like this, because if the only thing you need to do is type in someone's email and invite them to a tool like a screen like this that looks essentially like a web form, there is no barrier to entry. They don't have to be part of the release process or the deployment process. They can fill out that knowledge here, and this will get forward engineered on the next deployment back to Snowflake. In fact, you can get even a lot of this information, even if you didn't want to expose the tool to new users. You can download this whole thing to Excel and fill it out there and upload it right back to the tool. So if it's a one-time shot, send it over to your marketing team, product team, have them fill it out in a tool that they're already familiar with, filtering through Excel on their columns, on their tables, and there's no way to break the process. They just won't find a match if they screw something up. And anything they fill in here gets uploaded right back into the tool. So you can literally send it to multiple teams and they'll be filling out separate sections of the Excel. They don't overwrite each other. They don't step on each other's toes. And you have that information right back into the tool itself for everyone to be able to reference. And the other point I also wanted to make here, I still want to save some time for comments, so we're going to go kind of quickly, is we are talking about modeling in the traditional sense so far of dimensional modeling, relational modeling. How do we show that these things, these tables, these entities are connected? How do they relate to one another? But once you start leveraging Snowflake to its fullest potential, there's also movement, there's transformation, there's processes happening. So a modern tool should allow users to display more than just constraints and those kind of relationships. We should be able to model logical objects just as easily, because let's say we have a reseller analysis table. It is in no way connected to the fact reseller predictions table, aside from the fact that there's a procedure that actually scans this table and creates this one based on that analysis. So not only can we show that they are in fact related using virtual relationships, but we can drill into the code itself. So if we have the need to understand that process further, we can open that as the native procedure that we reverse engineered. It'll benefit from all the other screens of forward engineering, comparing revisions, etc. Which, by the way, I'll again just quickly demonstrate what that looks like. Change control. So let's just make some changes. Let's delete a table.
Well, while you're making changes, Serge, just
Yeah.
a kind reminder, we're 52 minutes in, and sorry I've been quiet, but there's been so many questions. I've been just typing away, just kind of getting the conversations going. Thank you for, I know there's sometimes a person asks a question and then you're showing right what they just asked. So that's
Nice.
fantastic. But leave me maybe 5 minutes.
Not
what-
even. I don't need that long. Let me just
Okay.
show you the most one of our most requested and most I guess sought after and this thing, view column lineage.
Good. I'm glad
are
you
a
got
little
to that
bit-
one. Yeah, that's a cool. This is a cool feature.
Yeah, unfortunately, I'm not building views anymore because this is something I've been waiting my whole life for and never really got to play with it in action. But at least I can demonstrate it and help other folks discover what a time saver this is. But anyway, to finish off on the release process, change tracking is again an integral part. So I was hinting at the fact that the procedures, the views, etc., all benefit from version control and the fact that you have lineage of all your changes labeled by sprint or release or change or etc. So it's not just a single static image, it's an actual audit trail of how did you get here? I can open a project from any previous revision and see actually what did this look like at sprint 7? What did we do between sprint 7 and sprint 8? So all of that is here, but let's not prolong the anticipation any further for views. So as I said, we have these two tables. We have a reporting view on top. So it's great that I could show that in a diagram to say it's not just the tables themselves. There's also logical objects. If I wanted to drill in and understand what that was doing, I can do that as well. I can analyze this. But this is a relatively simple view. So I've seen some hairy views in my life that have taken me upwards of 2 hours just to parse and understand. So what have we done? We've built column lineage analysis to help you quickly decipher what the intended idea is behind a view. So visually, you can see what it's doing, the inputs, the outputs. Let's take, for example, loyalty view, which we created in our last demo to reward our most frequent customers. So let's quickly understand, what is this doing? Okay, we're pulling from the customer table and the orders table. We're joining them. We're seeing which customers made how many orders, who are our top clients, how many points can we assign them, and understand that what the inputs are, what the outputs are. And if we did want to go further into more detail, we have syntax highlighting both from the editor as well as the tool itself. So we can understand what the actual formula is, where it gets created, how far does it go along the lineage trail, and save what could have been a 2-hour job or my entire morning basically trying to understand what somebody built, or if I'm a consultant or anything like that, I'm coming into a new company. It's right here at a glance. So it's just something that we've had such tremendous feedback on that just wanted to highlight that. And we can.
So this handles views on top of views, right?
Yeah, this handles views on top of views. And we're also adding scripts where you'll be able to take any kind of DML operation and understand it, even if it's completely unrelated.
Awesome.
Yeah, this is going to evolve into something really spectacular with
It already is.
Yeah, that's great already, because it is, in the data vault world, we do raw vaults and then business vaults and then various information marts on top of all of that. And so you could have multiple layers of views. And I know folks that have been doing that in Snowflake for years, where they have views on top of views, where the only thing that was physical in Snowflake was the raw data vault tables, and everything else from there forward was all done with views. But they're having to do that manually. And then if somebody says, hey, where did that value come from on this dashboard? That was, like you said, a 2-hour job to go back and say, okay, that dashboard is pointing at this view, it's pointing at that view, it's pointing at this view, and it's doing these transformations. And then it goes all the way back to the raw vault. You just solved that problem, right? It's like they can go in and instantly see that.
Yeah, so on Data Vault, we've also got, since you mentioned it, a lot of exciting things planned. So we can, if there's maybe, I'm sensing that a lot of these questions will be around that, so I don't want to jump the gun. If we have time, we'll look at these. If not, I do want to get to people's Q&A. So Anna, what have you prepared?
I guess what we should just say, we just leave it as a hint. More Data Vault stuff coming for SqlDBM, and now that we have Kent on our team as an advisor, he'll make sure we deliver what's needed. This will require a separate session if we talk about Data Vault, so let's save it for later. In the meantime, Kent, question here from our friend Shiva Nadison. In modern data teams, do we see data modeler or data architect modeler as a separate role, or other roles in data team are empowered to do the modeling role?
Boy, yeah, that really depends on the skill of the team and how big the team is. I've been, over the last couple of decades, I have been one in everything on some teams, and in some teams I am, the lead data modeler, and other teams I'm the lead data architect and I'm talking to the data modeler. So it's really going to depend on your team and how big the team is. The role has to be there for sure. You really do need that role, and it's going to be up to each organization and team to figure out, is there enough work that it is a separate person for that role, or do you have a data engineer who thinks diagrams are cool and can think in those terms and wants to build it that way? And so unfortunately, not a great answer. It's like everything in IT, it depends. It depends on who you're working with. If you're a big team, I recommend having, a dedicated, at least a lead data architect and or data modeler to help it, because you can have multiple teams doing development and one person kind of keeping the overview of the integrated model development and help you with that. But as it gets bigger, if you get to stuff that's like 10, 20,000 objects, then yeah, you're probably gonna need more than one person.
All right, all right. This kind of like, yeah, I'll save it as a separate snippet from the webinar. I love the answer, and we see a lot of use cases there. A lot of some people wear a lot of hats. Other teams are larger. Serge, there was a question. I forgot how it was phrased, but it was something about Confluence, and I forget. Did we had a chance to comment anything about Confluence?
No, I've been speeding through this thing that I forgot to mention Confluence. So let me just briefly share and see what that looks like. So outside of the tool itself, this is the reason that we've been hinting at cloud collaboration and integrations and
Communication, communication with non-technical users, cataloging, documentation, whatever you call it, right? The purpose is just to communicate what you've built.
Exactly. So the same thing that the modelers see, the same team that the developers see, is something that you can now embed in Confluence and share with your entire organization. So you don't even have to create a single user. You don't have to train them in SqlDBM. Everything is available in real time to the entire team. So everyone stays on the same page, no pun intended.
Yeah, they don't even need to know what SqlDBM is. You just give them the Confluence page, pretty much it. One more question, this in different shapes and forms, like multiple people asked. Serge, and I don't know, we have a separate YouTube video on this, but can you answer shortly? And Kent, please also maybe add flavor. How is SqlDBM is different or similar to DBT? What's the deal? SqlDBM, DBT. People are confused.
Yeah, it's completely different, and I understand the confusion because DBT talks about models, but DBT is for scripting, the data engineering aspect of moving the data and transforming the data and manipulating the data is really the focus of DBT, where SqlDBM is about designing and modeling the structures that the data lives in, whether it's the data in your stage tables or your dimensional model. The DBT may be what you use to move data and transform it from, say, the stage tables to the data vault tables, or from the data vault tables to dimensional models. So they're complementary in many regards, but it's really, DBT is a data engineering tool versus SqlDBM being a data modeling tool.
Yeah, another way to think about it is that DBT requires that the data already exist, that the data already be modeled, as in structure and data information in the tables themselves. There's no way to create an empty table declaring the columns and the data types in DBT. So that either has to come from into the warehouse from the source system, or it has to be defined as part of that source system.
That's a very good point.
Wonderful. And I do know that SqlDBM does have a little bit of support for DBT. Serge, do you want to say what we do?
Yeah, we understand that, as you said, it's kind of a handoff. It's complementary, and there needs to be a data model so you know what you're about to transform and where that data is going to move. So in addition to forward engineering in DDL, we're also now allowing users to generate YAML. So generate basically the entire source file with all that neat formatting that won't break your project, all the spacing, and all, most importantly, the documentation piece, since you've already taken the time to fill that out and gotten it from your business teams, that it goes into the source file as comments as well.
Wonderful. And I left some links to our previous session where you actually cover the SqlDBM and DBT. We're out of time, unfortunately. I've answered about 70-ish questions in the live chat, and I still have 61 to go. I might even take a second, record a separate video for some of them, the ones that are common. But this just tells me that how valuable this session has been to people. There's a lot of people from the community. We got some friends and family of SqlDBM. We got customers, partners, fans. So thank you, Kent, and thank you, Serge. The education around the topic seems like this is a very, very needed aspect that we can bring to the community.
Yeah, now
Excellent.
that people know the tool, next one could just be customer questions and more education around modeling, because it's like Ken said, it's a never-ending discussion. People sense that there's value there and they want to know more.
And of course, we got to do one specifically on supporting Data Vault.
Yes.
Absolutely, absolutely. Well, wonderful. Thank you, everyone who joined. Thanks again, Kent, Serge, SqlDBM team who helped put this together. This has been a great, and LinkedIn Live. So we've been all over the place. Have a beautiful rest of your day, and I'll see you out there somewhere in the data cloud.
Bye, everyone.
Bye now.